Waymo so far to date, up to date, has driven 4 million miles. This is a very high-spec vehicle. It has LiDAR, it has several cameras, it's extremely highly equipped. They have driven 4 million miles. You look at Nexar, we drive with a smartphone app. We've driven 100 million miles so far, and we're doing right now approximately exactly the same per year, 100 million miles per year. Yes, we only have vision data. We don't have LiDAR. And then you look at humans. Humans are leaving a trail back to the 120 billion clicks, right, that you were accumulating, or impressions. Humans are driving 10 trillion miles. Are we capturing that data? So when you look on the left, there's Waymo's new car. It was announced a few days ago. It still runs with equipment that is not accessible to you and I. It only runs with a few thousand units on test vehicles. In the middle, you have my son's Lego EV3, where he actually fitted and connected it to a server tool to do obstacle avoidance. And he fitted these two cameras. And on the right, you have Nexar app. So the two on the left, they are actually high-fidelity systems. Why? Because the data they generate is more than they can process, and they need to store it, and there's no way they can actually use it. If you look at what the LiDAR produces today in terms of data, is not able to actually use it in real time, all of it. It has to downsample to be able to run models with it. You cannot store all the data. The EV3 in the middle has two cameras, which is way more powerful than what an EV3 can do. Therefore, you have to offset it through the network to the cloud. The Nexar app, what we've done is the opposite. We basically said, I'm going to look at those 810 chips that run on the phones. I'm going to look at those 835 Snapdragon that run on the phone, and then feed the deep learning network to run on it. And then whatever data is left, I move it to the cloud. And that's what allows us to capture those 100 million miles. It's actually really optimizing for running on device. Which brings me to the third point. If you had 100 million miles per year, if you had tens of thousands of hundreds of thousands of users driving around the world, you're actually starting to learn from corner cases. You're learning about snow, about fog, you're learning about daytime, nighttime, twilight, you learn about driving in the desert, you're learning about driving in the cities. Back to the statistics, 50% of the casualties happen on the road in urban environments. Those 50% of the casualties are actually involving cyclists and pedestrians. Actually, 50% of these casualties are happening in Southeast Asia. And you have from the right, which is driving in Mountain View, driving in the Bay Area, at daytime, on a sunny day, it's easy. Driving in all these 1,400 cities in 80 different countries with all these weather conditions is hard. And there's no single automotive company that can do that. It has to be us, the people in this room, the people in this planet. We need to drive and collect data, which brings an issue of Big Brother, which I'll talk in a minute. And then the fourth one is collaborative management. When I drive today, we are the kings of our little castle, which is the car, and we can do whatever we like inside the car. As we go forward, and you look at autonomy, especially when you have humans and automatas driving together, you start having this issue around what if the robot fails? Because it will fail at some point. It's a system. And does the human take back control? If you look at what is called level 4 and level 5 automation, the human doesn't take control because there's no steering wheel in the vehicle. So what do we do now? How do we address those situations? One of them is to connect those vehicles. So what you have on the left is what we do today, which is a forward vehicle collision warning. In this case, there is a vehicle behind the corner that we don't see, and we know that if we continue ahead, we will hit the vehicle. So it's not a camera, it's somebody else connecting to us and telling us, hey, Bruno, watch out. Something out there, you should take that into account. On the right, you have some more advanced systems that is basically how do you negotiate an intersection without a traffic light, with all these agents are talking to each other. The reason this is necessary, by the way, is that at any point in the air, there are 10,000 planes, so you can do centralized air traffic control. At any point on the road, there are 250 million vehicles. So traffic management as we know it is not going to last.